Assalamualaikum, my name is Sabri Hakim bin Sadri. In this video, I will present my final year project, which the title is The Evaluation and Prediction of Mass Transport Properties for Cancellous Bone Structure and the Variation of Flow Rate. And my supervisor is Dr. Amir Putra bin Masad. This is the outline for this presentation. First, I will talk about the introduction and followed by my findings or literature review, methodology, result and discussion, and finally, the conclusion and recommendation for the future study. So, there are 4 subchapters in my introduction, which are the background study, problem statement, objective and the scope or the limitation while doing this project. So for my background of study, the bone marrow movement and the cancellous bone structure induce the mechanical stresses that act as a stimuli for the mechanobiological response. The routine activities such as walking, jogging, and others result in different loadings on the human bone. This variation in mechanical loading generate different bone strains that create the pressure difference in bone. The different flow rate of the bone marrow are generated from the variation of pressure difference, and this variation in flow rate induce the different shear stress levels that are experienced by bone cells. Next is my problem statement. The routine activities such as walking and jogging has their own average loading based on our body weight. So this variation loading is differ due to the variation of flow rate, and this study was focusing on evaluating pressure drop and shear stress under variation of flow rate to calculate the permeability of cancellous bone. The aim of this study are to develop the 3D model of cancellous bone structure under microcomputed tomography scanning, and to analyze the mass transport properties of cancellous bone structure under variation of flow rate. There consist 4 scopes in this study, which are using microcomputed tomography to scan a medial condyle that located at right femur bone, obtain 3D model by MIMIC software, trimetric software as approach to reconstruct and get more precise data for the 3D bone model, and using CFD approach to analyze the fluid flow through the cancellous bone. Some of subchapter from my literature review are the anatomy of bone, the mechanical forces, and the bone remodeling. So for the anatomy of bone, basically there are 2 types of bone, which are cortical bone and cancellous bone. And this study only focus on cancellous bone, where it consists of porous structure more than cortical bone. Next is this is the few types of mechanical forces in our bone and the bone remodeling that occur in our body. Next is the methodology. So there are 4 different software were applied in this study, which are MIMIC software, Trimetric, SolidWorks, and also Console. So the Console were used to analyze the CFD, to analyze the bone. So this is my flowchart. This is my flowchart, starting with the bone preparation and done through all the steps until finally we analyze the bone by using computational fluid dynamic approach by using Console multiphysics software. So firstly is the microcomputed tomography. So the micro-CT is used to scan the actual bone into 2D image dataset. Then the 2D image dataset will export to the MIMIC software. MIMIC software is used to convert the 2D image dataset that we get from the microcity to convert it into 3D image, and these few tabs or few feature that are used in the Mimit software, which are threshold, region growing, and we create 3D model. Trimatic software was used to reconstruct the bone model from the Mimit software. So in Trimatic, we use this software to smoothen the 3D model that we get from Mimit software. Other than that, we mesh the 3D model in this software, and in this study the total meshes is approximately 150,000 elements. For bonding condition, this study focusing on medial condyle that located at right femur bone. So the simulated body fluid or SBF is used as blood in human body with density 1000 kg per meter cube and dynamic viscosity 1 meter pascal second. The diameter of bone is 5 mm diameter and 5 mm length, and the length of the pipe through the chamber is 25 mm. So the permeability then be calculated by using the formula. The permeability then be calculated by using Darcy law formula. Next is for the result and discussion. All the result was gained by using CFD approach in COMSOL multiphysics. This section consists of the relationship between of certain parameter and flow rates. So first is a table fluid flow versus motor speed in RPM was created, and found that a linear correlation with motor speed versus RPM. Thus, this flow is valid to be used in this study to get other result. Next, for the Reynolds number, the Reynolds number was calculated by using Reynolds number formula, which equals to density times by velocity times by diameter and divided by viscosity. And a graph was plotted between Reynolds number and flow rate and found a linear correlation between them. So this graph was created to investigate whether the fluid flow is laminar or not, as the Darcy law equation only valid on the laminar flow. Otherwise, this study not success. So the result that we gain from the simulation is pressure drop. So the pressure drop was evaluated under 10 various of flow rates. The pressure drop and flow rate should follow a linear relationship as following to the experimental protocol, and this study showed a linear relationship between pressure drops and flow rate. Thus, these results indicate that this simulation study was success as it followed the testing protocol. Next is the pressure streamline and the contour. From the pressure contour, it is observed that the pressure at the inlet side is highest and decreased towards the outlet. Besides, the pressure inside the cancellous bone that located at the center of the chamber was variation in result. This is because of the porous structure of the cancellous bone keep changing from inlet and outlet, and leads to the acceleration of the fluid within the specimen. So next is the shear stress of flow rate. The shear stress result was gained after the simulation of this specimen complete. So the as variation in result as variation of flow rate applied, it is show that the shear stress increase as the flow rate increase. It is also shows that the movement on bone marrow with variation of flow rate induce the different shear stress levels that are experienced by bone cells. Next is the shear stress contour. So it was found that the maximum shear stress located at the center of the bone that of the specimen in the chamber, while the minimum of the shear stress located at the yearly inlet section of the chamber, as shown in the figure. So lastly, this study was aimed to predict and evaluate the permeability of cancellous bone under different flow rate. The pressure difference and shear stress obtained in this simulation will be used to calculate the permeability of the specimen by using Darcy law equation. So as the result, the permeability is remain unchanged under lower flow rate, and however, due to the higher flow rate applied, the permeability decreasing slightly as shown in the slide. As a conclusion, the numerical analysis with CFD provides the potential assistance for analyzing the cancellous bone in effective way. Next, the different flow rate that has been used, resulting the different values of the fluid pressure in the different behavior. A linear relationship was found in this study between the pressure difference and the shear stress, with increasing the variation of flow rate. The permeability decreasing as the pressure difference and shear stress increasing. And lastly, the permeability result in this study is exponent -9 compared to the previous permeability study, which is in average from exponent -9 until from to exponent -12. Last but not least, the recommendation that I would like to suggest in this study for further study is adding the RAM to the computer that we need to use for analysis studies. We also should simulate the bone with the higher tetrahedral element so that we can get the precise data from the simulation. And lastly, we also should to minimize the reconstruction of bone, because to maintain the actual bone structure. And that's all from me. Thank you.